Welcome to our video about permutations with restrictions. This is definitely top level. Yeah, for sure get a good handle on fundamental counting principle and basic permutations before having a go at these ones. So this links in with the third credit assignment. Here we have 6 unique markers. You can see hopefully that they are different colors, but I'm going to kind of group them and say these are all orange-ish and that these are purple-ish, but that they are meant to be like different colors. So they're not supposed to be the same or duplicates. So let's just say that the restriction that's being put on this permutation is that these markers have to be alternating. So how many different ways could I order these markers so that they're alternating? Yeah, that's our keyword, alternating. So one way to alternate, so we've got 6 markers that we've got to put down. One way to alternate is to start with orange first. So any one of my oranges could go first. So there's 3 choices for the first pick. And then in order to be alternating, I need to put a purple. So again, I have 3 choices here. Then I need another orange. Then I need another purple. And then lastly, there's only one more pick for the last orange and one more pick for the last purple. So there was 36 different ways to alternate them like that. But the problem is that it didn't say that orange had to be first. So there's another way to do alternating, but with purple first. So it'll be purple, orange, purple, orange, purple, orange. So again, we've got 3 choices for the first purple, 3 choices for the first orange. You can see where this is going. Whoops. So there's 36 different ways to do it with orange first, and there's 36 different ways to do it with the purple first. So the total is going to be those 2 values added together to make 72. So there's a total of 72 different ways for these guys to be alternating. So I'm putting some more restrictions on these now. So we're, again, finding how many ways, blah, blah, blah. How many ways could we arrange them so that purple must be in the middle? And in order to do this, we still have our 6 markers, but we're saying that the purple-ish markers have to be in the middle. So I like to write that underneath the placeholder for them. So I have any of these guys. I would also take care of your restrictions first. So any of those could go in the middle spots. So right now I've got 3 markers to pick from for the first purple. I've got 2 markers to pick from for the second. And now when I'm going to fill in, I'm going to go from left to right, I have 4 remaining. Yeah, there's 1 purple and the 3 oranges. So any of these 4 could be on the very outside end. Then I've got 3, and then 2, and then 1. So 144 different ways that we could arrange these so that purple's in the middle. How could we arrange them so that purple is not first, or purple-ish one is not first? So what do we have here? How many ways, how many options do we have for this spot? Well, there's 3 options of markers that are not purple. So we could put any one of those 3 down in the first spot. Then in the next spot, there's no restrictions. So we're back to having our full choice. So we'd have 5 markers to pick from for the second. And then our last one, what if a purplish marker has to be on either end? So I would make my placeholders. I would say I have to have a purple here. I have to have a purple here. There's 3 options for this first purple. Now there's only 2 options for the second purple. And we go back to filling in the center and saying, okay, I've got 4, 3, 2, 1. Now, I'm just going to kick it up a notch here with one last question. So same idea, same purple-ish and orange-ish markers. But I'm saying that the purple must be together. And this word together to me is like a really big keyword. When I see that in a question, it's red flags. I'm thinking about another word called chunking. So what we're going to do is chunk those purples. And what that means is as soon as one purple goes down, you have to put the other purples down beside it. They have to be together. So, so I think about them as one unit, as one chunk. These guys are, we don't care about the orange, whether they're together or not. So these purple guys, I like to group them together. And we can see that there's 3 of them that are part of that group. And we can put them in any order, you know, any of the 3 could be first, then 2, and then 1. So I treat that as one group or one chunk and the rest of the other markers, because I could pick any one of these purple markers or I could pick any of the 3, 2, or 1 orange markers. So we've got 3 orange markers and 1 chunk of purple. So in order to represent this, we would sort of represent it as the 4 factorial, which shows the 3 orange options, or the 3 non-purple options, and the 1 option for the chunk, but just 1 for the chunk. And within the chunk, it's the 3 factorial for how those markers get put down. So I'd like to just kind of reset, because this chunking thing is a little bit tricky. So I'd like to just kind of reset and add in some more, just so we're not using the same numbers all the time, add in some more colors. So we've got all of our purple and orange markers, but I've added in a set of greenish markers. So again, they're all meant to be unique, but we could call these 3 our greenish markers. So if we want to arrange them where the green ones are going to be together, we see that there's 3 green markers. So they could be arranged within their chunk as the 3 factorial. Any of the 3 first, then 2, then 1. But that's just one option out of the whole group. So now I've got a total of 9 markers altogether. 6 of which, like, I don't really care about. They're not in a chunk. and one that is a chunk. So 6 plus 1 to make 7. So altogether, we've got the 7 factorial, because it could be one of the green markers or any of the other 6. And we've got the 3 factorial to represent the ways of being arranged within the chunk. These numbers are getting big. Now, the last question is a bit of a trick question, especially if you didn't watch this video. The greens must be apart. There's so many ways that greens can be apart. This is not something that with fundamental counting principle we can actually calculate. We can't directly calculate it, but we can indirectly using the complement. So, because the word apart is like saying together, but not together. So what we need to know is the total ways of them being, and we can subtract off the total ways that they are together. So you've got 9 markers altogether. So there's 9 factorial for just the total ways that we could arrange them. Minus off the total ways that they're together. So let's find out what's the 9 factorial is 362,880. So what we have here is we have all the ways that we could arrange the 9, subtracting off the ways where the greens are together. And what that leaves us with are the ways that they are not together, or basically apart. Tricky stuff. Devil's in the details, so make sure you're looking for those keywords.